Abdul would be able to tell you if this telescope is available for you to borrow once those restrictions are removed. And you could borrow this telescope, take it out, and learn how to do some astrophotography with it. So it's available to your members. Abdul will be able to tell you if this telescope is available for you to borrow once those restrictions. Sorry, so this telescope is definitely available to borrow whenever the restrictions are lifted.
So if anybody has any questions, you can ask them through the chat if you like.
Well, and since we're on a meeting, you can just turn your mic on and ask away. It's a little hot in the garage here.
Hey, Gord, I have a question.
Sure.
When the camera is on the ETX, does the computer know not to go too far north so it doesn't smash into the mount?
No. So you need to be careful about that. So this telescope can't point at the pole area with anything on this here, right? So if I undo the deck, you'll see there's virtually no room between the back of the telescope. So if you wanted to look at something at the pole, this is not a good telescope for doing. The telescope is intended to be looking a little bit further down, because really, you know, with a big camera on the back, you're going to hit this at a relatively low altitude, right? So if you are pointing north, right, that becomes a problem. But you know, there's not a lot of super interesting stuff sort of due north. Oops. And you know, it does have a limitation that, you know, it can't go much lower than about 15 degrees, right, pointing south. But of course, again, you're not usually looking at stuff below 15 degrees. It's too mucky. So it otherwise has a good range of motion, but it is fork mounted as well. So if you put something really heavy, now you'll notice it's pretty nose heavy, which is good, because if you put a camera on the back, it's fairly well balanced. There's no way to balance this either front to back or side to side. That's a defect of the fork mount system. That's why most people go with something like this. If you look at this telescope, this is a German equatorial mount, right? And it doesn't have that issue. It can happily point north or anywhere you want. It doesn't have any limitations, but obviously this is a rather beefier mount than that one. This is not as portable. So obviously this is where the ETX 125 really shines, is that it's quite portable, right? So you can take it out pretty much anywhere. And it's, you know, even if you have some physical limitations, you can still use it pretty effectively. You know, as long as you're able to lift the telescope onto the mount, it's not overly heavy, then, you know, you won't have any trouble physically using this telescope, as opposed to a telescope like that.
I have two quick questions.
Sure, go ahead.
How do you stop it if it starts ramming into something on there?
Well,
and
you basically on the handpad. On the handpad, if you hit mode, right, it'll start backing out. And I think actually the question mark is an abort. And basically it's like an escape button. So you can stop it and it'll back you right out.
Okay, and if you loosen the clutches, does that ruin the alignment?
Yes.
Okay, thanks.
Now, but you can be tricky, right? Because if you really mess up your home position and you want to get the telescope to be pointing at Arcturus, for example, and you're really far off, then you can loosen the clutches pointed at Arcturus, and you know, it's as if it was properly set up. So you can use the clutches strategically, but yeah, you don't, when it's all aligned and you've been using it for a while, so it's kind of dialed in the internal model, yeah, you don't want to undo the clutches, and you don't want it to hit the mount, or you'll have to do a realign.
Judy has a question.
Judy has a question.
Yeah, Gord, once you focus on an object to take a picture, and you take a picture or 5, and then you decide to go to a different object, would you need to refocus, or is it pretty stable?
You need to check the focus. It's pretty stable, but you need to check the focus because, even in a small system like this, there'll be some flexibility in the materials of the telescope. So you do want to check it. You just don't want to focus once at the beginning of the evening and then just don't focus again because it will soften.
Okay.
Now, especially if you're focusing on some terrestrial object and then you go to an astronomy object, you definitely need to refocus because the focus will be much different. So generally, when I'm taking pictures, I focus every time, because of course my telescope does it for me, so it's not such a big hassle. But yeah, you do want to check the focus at least.
And Gord, we have another question from Kathy and Ed.
Well, it's actually just Ed here. Sorry. Yeah, no, thanks for the great presentation, Gord. The question I had is, do you know what is the difference between a Schmidt-Cassegrainian and a Maksutov-Cassegrainian? And if this was a Schmidt-Cassegrainian, would it be kind of the same configuration, or would the scope fit a little differently?
No, so the difference between a Mac and an SCT is that the SCT, the lens in the front in an SCT is thin, and it's been formed into it looks like a valley and a peak in a valley, or sorry, a valley in the middle and two peaks, and then a valley on the other side. And the purpose of that is that it deflects the light as it comes through the corrector plate, as it's called, and it deflects it such that it hits a spherical mirror and it doesn't cause spherical aberration, which will cause your objects to go out of focus. So what this does is it's a curved meniscus. It basically does the same thing, except this is not the same. I forget what a Mac. I think the Maksutov is actually a paraboloid mirror, whereas a Schmidt-Cassegrain is actually a spherical mirror and a spherical secondary. So they're very easy to fabricate, but that corrector lens is not very easy to fabricate. So it's just two different designs. Macs, because they have a really thick glass lens, you don't see very large Maksutovs. You don't see 16-inch Maksutovs very often. You see this small 4-inch, 100 millimeter to 150 millimeter Macs. Whereas on Schmidt-Cassegrains, you see 16-inch. Celestron used to make a 24-inch SCT. So it's easier to fabricate the SCTs. But generally, form factor-wise, they're exactly the same. As a matter of fact, we have an 8-inch SCT at the observatory. I'm just going to cancel my timer here. There we go. We have an 8-inch SCT, which is actually on one of these fork mounts as well. And we're looking to get a wedge for it so that we can make it a EQ mounting. Right now it's alt-azimuth, so it's straight up and down, and that's not suitable for photography. So basically that's the difference.
Great, thank you very much.
All right, Gord.
And that's my time, so I'll turn it back to you, Dennis.
Great, thank you very much, Gord. So if you can stop sharing screen, and then I'll move in to share screen. Perfect.
There we go.
All right. Well, welcome everybody tonight. We're going to start our regular meeting at this point now. And those who joined us earlier, again, thank you to Gord Tulloch for doing the beginner session on using the ETX 125 loaner scope. So again, I'm going to just do a treaty acknowledgement for those that are joining us for the rest of the evening. The lands from which our members and guests are joining us are located on original lands of Anishinaabe, Cree, Ojibwe, Dakota, and Dene peoples, and on the homeland of the Métis Nation. We respect the treaties that were made on these territories. We acknowledge the harms and mistakes of the past, and we dedicate ourselves to move forward in partnership with Indigenous communities in a spirit of reconciliation and collaboration. So this evening, The format is going to be our beginner session, which we've already done, followed by the meeting announcements, which I'll go over in just a minute, and then what's up with Jay, what's new with Michelle. We'll have our break. Tonight's break is going to be slightly different. We have 2 breakout rooms. One's just where we can visit, and then the other one, Judy will lead. We'll talk a little bit about imaging. And then starting about 8:30, our main presentation with Wilfred Buck, who will chat to us tonight a little bit about what our skies look like from the Indigenous perspective of Canada, which is really important to see. And then afterwards, of course, there's time for the virtual get-together. So just some of the announcements. We're working slowly, as we've mentioned before, through incorporation. Bylaws, we have our first draft done, and we've actually submitted to National to do a review to see how things are. I will go over a couple of slides, just briefly giving you a little bit of a feeling of what they're going to look like. Operations manual is happening, strategic plan, the mission, vision, and values are almost cemented now. And then probably at our next meeting, we will present those to you as well. Our mentor program, we're recruiting volunteers. Interim volunteer coordinator is Judy. And shortly, we'll be sending out applications, if you like, for both mentors and those that wish to be paired up with a mentor to kind of figure out what people are looking for. Light pollution abatement work continues with NCC. Just a reminder about on September 29th, we will have the youth outreach program at the local scout camp in Winnipeg. Public outreach, because of the current restrictions, is still not happening, but we do hope to, by the fall, be into public outreach programs again. Glen Lee, we will send out an announcement once the latest health order kicks in to let everybody know what can be done at Glen Lee at that time. We still are planning to have the Sprucewood Star Party in a September long weekend. And the July meeting, we do plan to be the barbecue at Glen Lee with an alternate location for the rain, and we'll post that on the forum. So what's going to happen is, as we've mentioned before, we're going to be incorporated as a nonprofit without share capital in the province of Manitoba, primarily to allow us to tap into grant opportunities to be able to do more of our outreach and any improvements and upgrades to Glen Lee as the membership determines. So we will not be a charitable organization. We will strictly be a not-for-profit. Just pulled a couple of things out to give you an idea of what we're looking at. For incorporation, we have directors, and these people are actually listed on the incorporation every year after the elections. Primarily made up of the president, vice president, secretary, and treasurer, and then 4 at large. They all have voting privileges on the council, and they must meet the criteria required by the Corporation Act. In the case of a tie, the president can opt to have a second vote or let the motion die. The privilege of a second vote can only be used by the elected president, is not passed to the person presiding over a meeting in their place. So the president, VP, secretary, and treasurer are officers and make up the executive of the council. And these positions, along with the others, will be submitted annually, as I mentioned. Now, we also have councillors that will be elected. And the reason we have 4 more councillors is this allows our youth members to actually participate in council and have a vote. However, because they're underage, they will not meet the requirements for the Manitoba Incorporations Act, so they will not be included on the annual report. However, as per the bylaws, we're still getting this all reviewed, they would still have a vote. And then as a minimum would be the 4 executive positions, which is what we have to, as a minimum, have every year in order at the AGM. It was decided we would only have 2 standing committees, finance and nominating. And the other functions of the other committees would be struck as required or ad hoc. And they'll be how they're run and what they're used for will be contained in the policy and procedures manual. And that will come out probably later in the year. And again, it's meant to meet the needs of the membership, not necessarily be ensconced in law. But the finance committee needs to meet every year. and have things in place, budgets, etc. And also the nominating committees as a mandatory part of the act. So those are kind of the key points for that we picked to pull out tonight. So with that, what I would like to do now is introduce Jay Anderson. Jay is a longtime member of the Winnipeg Center, as well as he's also one of the ones that work with Judy to go out early in the morning to try and catch 30 pictures for us. And tonight I would like to welcome Jay Anderson.
Thank you very much, Dennis. You let me share my screen here, I guess. Where am I? I've lost the share screen button. Or have you not sent it off to me yet?
You should be able to share your screen.
Oh, where's the button gone to now? Here we go. Got it. So we have kind of a quiet, come on, speak to me. We have a quiet month this month, first of all, because we don't have very much darkness. And secondly, because not a lot is happening up in the sky. On the right-hand side there, you can see some pictures that Judy took of the recent lunar eclipse 2 weeks ago. The top two pictures are the moon being eclipsed by the Earth's shadow, and the bottom picture is the moon being eclipsed by the Earth as it sets. And you can see how the seeing and sharpness decreased rather abruptly as the moon got lower and lower in the sky. We were lucky to find a little bit of a hole in this cloud cover by traveling west to Winnipeg at some ungodly hour of the morning. Well, we start with the sun as usual, 2 sunspots on the sun, and actually that's a smaller number than had been the case 3 days before that, where there were 4 of them. It's the first time we've seen 4 sunspots on the sun for quite a long time, certainly a year and a half or more. You can see from the sunspot cycle progression graph there that numbers are still trending higher than predicted, which is, if you're looking for aurora and solar activity and prominences and flares on the sun, that's a good sign. Watching a flare on the sun in white light is quite an interesting process. They last, half hour, 45 minutes, an hour, and they're pretty easy to spot without a hydrogen alpha filter, and even easier with an H alpha filter. So if you're lucky and happen to be watching the sun in the years that come by and one of those flares kicks off, it'll be a real treat for you. In the sky, here we are looking at tomorrow's sky. The Virgo galaxies are still overhead here in the middle, sort of 45 degrees up in the sky. But this is at 10:30 p.m., pretty light out at that time period. And looking at faint galaxies in a sort of not quite dark sky is probably not as rewarding as experience as it would be in the darker skies in March and April. But the best thing about the sky at this time is that Scorpius and the star Antares are moving into the southern position, and at 10:30 they're still rising up in the southeast sky. But as we go over to 1 a.m., you can see Scorpius is now down in here, Sagittarius, Scorpius, and that makes it a very, very tempting target for photography and for viewing. And you see in my graph here, all these M object, Messier objects. This area is one of the most rewarding areas in the entire sky for looking at the various forms of nebula and subglobular clusters in there, and a lot of open clusters as well. So anywhere along the Milky Way band from Cygnus right down into Pascutum and into Scorpius and Sagittarius is probably the richest part of the sky for us. Unfortunately, it's here at 1 a.m., whereas if we wait until the fall, it's right there at 8 o'clock in the evening when the sun goes down. So it's something you can explore a little bit. It has the advantage of being farther south, so the north part of the sky is going to be fairly bright because the sun's not too far below the horizon, but the south part of the sky will be the darkest part of the sky, particularly if you're on the south side of the city and looking southward. So there's a couple of little treats in here for something high up, the North American Nebula up here by the star Deneb. And that's easy to find and much harder to see. And then we have the other stars of the summer triangle. Here is Lyrae in here, and Altair down in here. So triangle is these three bright stars. And you'll learn a lot more about that as we go on into August and September, and they become much more prominent in the evening sky. Take a look at the Milky Way at this time. This is the Milky Way in the evening as it's rising. This was taken a month ago, and we got some bright cities and an enormous amount of green sky glow that night. Had to process a lot out of it. But here is what I mean when I'm talking about the Milky Way. The Scorpius part of it in here was actually below my horizon, or on the horizon, but here we have the North American Nebula up in here, and this very rich area is certainly worth exploring with binoculars, with telescopes, and with cameras. And you can get these kind of pictures without even having a tracking camera. You can just put the camera on a tripod and take a whole pile of 5 and 10 or 20-second exposures, depending on your lens, and just use some free software to pack them all together and come out with a picture like this. Hopefully you pick your site a little better so you're not looking at Morden, and this is Winnipeg. So that's Winnipeg, 170 kilometers away from the site. Got to go a long way to get dark. Looking into that Scorpius Antares area, you'll probably recognize a little bit of this stuff because Sheila sent some pictures out of this area. This is an interesting area around the bright star Antares here. So this is going to be low down in the sky, but even with short exposures using the technique I just described, you can see these star clouds. This is an interesting set of clouds. There's a lot of colors in this, and they all mean something. And one thing Judy and I have been talking about is how you should be looking at your images to see what you see, not just a pretty bunch of colors. And in this case, we see a couple of interesting things. Antares is a very red star, and all of this reddish glow here and down in this area is actually reflected light from Antares. It's being reflected off of dust and gas, which is in the enormous nebula in behind it. Up here we have a blue star. This is a much hotter star than Antares, and it's hot enough that the ultraviolet radiation from it and the blue light from it extremely intense, and it's reflecting off of this dust and gas. But because the star is a different color, the reflection is a different color. And so here we get red, and here we get blue light from Antares. Over on this side, we have another bright blue star.
Sorry, I'm gonna plug my headphones in here.
Getting an interloper. Anyway, over here you have another bright blue star, but this time the ultraviolet radiation is causing the hydrogen gas in behind it to fluoresce. And of course, we have a big globular cluster here and a small globular cluster here, and this one's colored a little red because it's behind this dust and gas. So there's lots of stuff in that area, and you can photograph it with a pretty small camera on a tripod. So we look at the planets. Mercury is now behind the sun, but next month it'll be coming out, and it'll be the best that it's going to be in the morning sky on the 9th. Not very high, but it'll be reasonably bright and easy to find with binoculars. Venus, of course, is always easy to find in the evening, getting a little bit higher over the next few weeks. on the 24th, it reaches its highest point and then it begins to sink back toward the sun. But because it's at magnitude 4, it's not a problem to find it. Mars is a little higher and left of Venus on the trailing along behind it. But you can see its magnitude is down almost to 2 now. So it's 6 magnitudes fainter than Venus. And so it won't stand out very dramatically. Jupiter is rising about 1:30, and that'll move ahead 2 hours as we get into July. So it'll be rising earlier in the evening. It's part of the ecliptic, which is fairly low down. So even though it's getting farther into the dark skies, it doesn't reach a very high altitude, only getting up to about 25 degrees high. So about 1/4 of the way up in the sky. Saturn's a little bit higher. It's in front of Jupiter. Again, you can see there's a 3 magnitude difference between the two, so it won't be nearly as prominent as Jupiter. Uranus is behind the sun. Hard to find because it's in the twilight in the morning. Probably best forgotten for at least a month or more. And Neptune is sort of in line with Jupiter and Saturn. So you take the distance between Jupiter and Saturn and extend that behind the same distance behind Jupiter toward the east, you'll run into Neptune. It's up and visible all night, but you'll have to go looking for it with telescope because it's not visible to the eye. Here we have a picture of getting Moon and Venus are together tonight, actually, very close, and it doesn't look like anybody's going to see that. And Mars, you can see, is trailing quite a bit farther behind, and in this depiction, you can see that it's shown to be quite a bit dimmer than Venus. Not much to see on comets. Comet Palomar is still around. It's still at 10th magnitude. It's pretty much the same brightness that it was last month when I talked about it. It's not a particularly impressive comet, just a sort of round circular coma, but it's easy to find because it's underneath Arcturus, and Arcturus is a bright star that's easy to spot. So through the month, it'll sort of be moving along this track in this direction, and that's about as far as it'll move in the month. So if you need a comet to satisfy whatever cravings you have, well, this is the best one you're going to be able to get. Some pretty pictures, again, not much. I want to talk about noctilucent clouds a little bit because it's now the season for them. June 22 to 4, Mars is moving through the beehive. Here's a picture of it on the 23rd. It's smack in the middle of the beehive cluster, which is this circular outline here. So the big thing about it is it's very low in the sky. And of course, we don't get that dark, so it'll be a real challenge to photograph, but a very pretty picture if you do manage to get a shot of it. You have to get out early as twilight begins to darken and try to capture it. And on June 28th, Moon passes under Jupiter and Saturn, not particularly close, but they'll make a little bit of a nice triangle here. This gives you a rough idea of how far Saturn and Jupiter are apart. So they're about 40 diameters of the moon separating, and Neptune is the same distance farther back toward the east, away from them. So this is June 28th at 1 in the morning, darkest part of the night when the moon passes under these two. Noctilucent clouds. Noctilucent clouds are really high clouds up in the sort of 80 kilometer altitude. They're the brightest or the highest clouds that we have around the Earth that take a very cold temperature to form. And it turns out that while the northern hemisphere warms in the summer, the high altitudes over the northern hemisphere actually cool. And so at this time of year, the mesosphere, which is where noctilucent clouds are, is at its coldest temperatures. It has to be below minus 120 Celsius to take the little tiny bit of moisture that's up there and turn it into clouds. So you look at them from deep twilight, you can see that this is, the sun is getting lower and lower during the time of this picture, and the clouds are first illuminated quite high up here, but as the sun sinks, the clouds that are illuminated sink more and more toward the horizon. They're not hard to see. This set of pictures is taken from the Assiniboine Park. Recently, they seem to be becoming more and more frequent. They're already starting to see reports of them from Europe and parts of the more northerly parts of North America. So something to keep an eye on until the end of August, which by that time the sun sinks down below the horizon so quickly, there's only a very short time period to see them. And so we get to the cat. This is an antique that popped up for sale. No idea what it sold for, but I found it on, or Judy found it on the antique page, but a cat looking at a star chart and a telescope. I guess it's looking at Cassiopeia. So thank you very much for putting up with that pun and everything else.
Thank you very much, Jay. There was one question. Can the comet 2020 be seen with binoculars?
Well, that boils down to whether you can see a 10th magnitude object in not completely dark skies. It would be a real challenge. I'd say no, but I think with 15 power binoculars resting on a tripod, or go out and borrow Steve's big 5-inch or 4-inch binoculars, then you'd see it in those. But 10th magnitude, no. You could photograph it very quickly with 15 seconds, but it would just be a dot in the sky.
All right. Thanks very much, Jay. Doesn't look like there's any other questions. So our next speaker is Dr. Michelle Boyce. And again, I'd just like, before she comes on, just like to welcome everyone who's joined us, who's on Facebook Live and YouTube Live. So Michelle, if you're ready to go, please go ahead and start sharing your screen.
When it gives me permission. It says host disable.
That's me. I didn't realize that your name was different from
Oh,
Michelle.
yeah.
So I didn't make you co-host. I'm doing it now.
Okay.
Thanks, Scott.
2. Okay. 1 second. I'll try that again. Can everyone see that?
Yes.
Okay. Okay, so these are selected topics of what's new. So one topic I found was interesting. Could protoplanetary disks be sticky like molasses? So basically, the idea is that you know, the typical accretion star formation thing where you have a gas cloud and it slowly condenses and then starts to spiral in towards the center of mass, which forms the star and then forms a disk. But if you think about the physical laws that are involved, you have stuff falling in, and so it's accreting, so it has to be losing energy. And yet, at the same time, you have these planetoids or planets that are starting to form and they're orbiting. And so so naturally you would think those would also be pulled in, but according to our gravitational kinematics, they form circular orbits. So we have to somehow account for that energy loss. And so there's this model, there's a set of equations by Sakura Suyaneth that includes a viscous term. So they say, well, there's some viscosity there, so that's what's losing energy. Somehow there's some mechanism where you're losing it, say, to viscosity, and it gets lost as heat or something like that. So the energy is lost and it starts, so the disk can, the matter can spiral in and so forth. And so it's surprising because I had thought that we pretty much had a handle on how planetary systems form, although there are quite a bit of details. But there is this slight puzzle. And what this person here, Roman Rifkoff, did was look at 26 protoplanetary disks. So these are examples here of protoplanetary disks that he looked at. And you can see here, these lanes are where the planets are, and they're sweeping lanes out, and the matter is accreting inwards. So what he did was, from previous studies, he looked at what's called the accretion rate, which is the rate at which the material is falling into the star. And then using that set of equations, he could calculate the viscosity. And he did that for each one and put them on this plot. So these are all the different ones he looked at. And he got this sort of linear relationship. So it says, okay, so maybe there is some kind of viscosity going on, and maybe it's sticky like honey, you know, swirling in. But the problem is they don't know what kind of mechanism would do that. So they'd have to know more details. So either there's something they don't know, or there's more complex physics at play here. So more research is needed. So that's basically this article. This axis is the viscosity, and this is the accretion rate in solar masses per year. So,
No.
yeah, it's interesting. Okay, and sometimes I dig down rabbit holes and give you more detail. I didn't on this subject, but next subject. I found this interesting. The Milky Way has ultra high energy cosmic rays. The experiment, the Large High Altitude Air Shower Observatory, which is currently under construction in China. It's half completed, but usable. And they started using this detector and discovered, hey, these cosmic rays are coming from our own Milky Way, these ultra high energy cosmic rays, which is about 10 to the 18th electron volts, which is a measure of energy that particle physicists use. That's the mass energy equivalent of 10 to the 10 protons. And if you want, it's 10 to the minus 14 grams mass equivalent. But it's still, anyway. So the origins of these aren't from where we would traditionally think they're from. So I'm going to dig down a bit into this particular rabbit hole, explain what cosmic rays are, where we think they come from, and how we detect them. And I'm really going to talk more about high energy cosmic rays, because the entire subject of cosmic rays is quite complex. Because if you look at extreme low energy, you have cosmic winds coming from the sun and all sorts of particles. It's an amazing mess. Although they all have the same fundamental building blocks behind it and similar detection techniques. So what are cosmic rays? Well, this is a rather schematic diagram. And when you see these, any of these splittings here is in the presence of a large atom, such as an air molecule, which triggers these events. So you could have some highly energetic particle coming in. It smacks an air molecule apart into kaons, pions, all sorts of things, or smacks out neutrons and protons. And then you get high energy photons, which can pair-produce. Again, every node here in the presence of an atom can produce an electron-positron pair, and that can be slowed down by the air and produce what's called Bremsstrahlung or shrink-off radiation. And so you get this entire mess of this entire spray of particles. So, and just quickly, this is all in terms of the fundamental particles. So I'm just quickly showing you the fundamental particles behind all this. So the simplest way to think of all these fundamental particles is what makes up an atom. And you have your electron, which is whizzing around, and it's held or mediated by a photon. And then inside the nucleus, here I have a proton and a neutron. They're made up of up and down quarks in various combinations to give either neutral charge or positive charge, and they're held together by gluons. The nucleons themselves are actually held together by a cloud of quark-antiquark pairs, which make up mesons. So these things here that you see pi plus, pi minus, k plus, k minus, those are all quark antiquark pairs, and they give different charges and different masses. And that comes from this spectra on the right. So you can see here's the up-down quark, which makes predominantly most matter that we see. And then when you add more energy, you can get charm, strange, top, bottom. And if you add these in combinations of quark antiquark pairs, you can see you can get a whole plethora of different particles. Hello? Someone's got their mic open, I guess, or that was a question. Okay. Anyway, so that just gives you an idea of the entire zoo of particles. This is the standard model of particle physics. And you can see the quarks come in these pairs or doublets. The same, we have an electron, neutrino, muon, neutrino, tauon, neutrino. And so these all have mass, and these are essentially massless. I'm putting quotes around that because that's not quite true. These are called leptons. These are quarks. These are, they all carry charge, so they're mediated by photon, but there's other particles here which mediate interactions between them. It's complex, but that's just in a nutshell what you're seeing in this air shower. It's quite a complicated mess if you look underneath the hood, but in general, it's a fairly simplistic. Hindsight is 20/20. Anyway, so what are the origins? The origins of cosmic rays, especially high energy cosmic rays, are thought to come from jets from accreting black holes. So there's black holes, matter is pulled in towards it, forms an accretion disk. That disk heats up, and it's just like our solar system formation, except it's much hotter, much more intense. And as it gets towards the middle, the black hole tries to swallow it up, but it can't, so it spits out two jets coming out either end to conserve momentum. And those jets are full of highly energetic particles, so highly energetic electrons and gamma rays and so forth. And in general, this is thought to be the source of the high energy rays. So it is a bit interesting that we found them coming from our galaxy. I'm a bit skeptical about the whole thing, so we'll wait and see, because it would be interesting to know what kind of sources do that. So how do we detect them? Now, this is a complicated mess, but essentially, this is our atmosphere. This is your brain on the atmosphere. Sorry, borrowed it from somewhere. When a particle comes through the atmosphere, depending on its energy, will depend on how far down into the atmosphere it gets. So some require high altitude balloon experiments to measure low energy cosmic rays, and some satellites. And then on the ground, some are so powerful that they will make it to the surface, and you get what's called air showers, which is just showers of pions and so forth. In the end, what happens is you get what's called a light cone, or Cherenkov light cone, that you get in nuclear reactors, and you can measure that. It's in the blue to ultraviolet range, that light. You can also detect muons. What they typically do for that, so a muon is a heavy electron, or neutrinos, what they typically do is do that underground, because then that filters out all the other junk. It doesn't make it through the surface, and so they can measure it underground. Then you have these optical type reflectors with scintillators and so forth. So there's about different modes of Cherenkov detectors. They're kind of like reflector telescopes with photomultiplier tubes. I'm going to get into that shortly. Neutrino detectors, such as the Sudbury Neutrino Observatory, a large tank of water that scintillates when something hits it, knocks an electron at relativistic speeds, and basically a Cherenkov light cone in there is the equivalent of basically a particle traveling faster than the speed of light in a medium. Just as an aircraft, when it travels faster than the speed of sound, produces a shock wave, the equivalent is a shock wave of light in the blue to ultraviolet. That's why when you see nuclear reactors, you see that kind of glowy color. And muon detectors. So I'll just quickly look at that three classes of detectors and then put that back into perspective. So all these detectors, pretty much all of them, all end up funneling light funneling that information as either a charged particle, whatever, and is eventually converted into light. That light is channeled somewhere and eventually is picked up by what's called a photomultiplier tube. It's like the old Caffrey ray tubes for TV, but in reverse. So when a photon hits the surface of this scintillating or photocathode, it ejects an electron, which is due to the photoelectric effect. There's a strong field here. It hits this plate. It's attracted to this plate, which then ejects 2 electrons, and those 2 electrons eject 2 electrons, and so on, if you recall the shampoo commercial. So eventually you get enough energy here that you can detect on your readout, and you can actually tell what the energy of the photon is, and so forth. So this is at the heart of all of these detectors. This is the heart of it. So a scintillating detector consists of these plastic, they're actually, if you look at it, it's a clear plastic and there's kind of a bluish tinge to it. And it's wrapped in electrician's tape, so no light leaks out. And when a particle hits it, it actually hits something in here and causes light to be given off, and that light is collected in the photomultiplier tube. This is a triple coincidence detector. Over here we have a simple one called a coincidence detector, which only counts it as a detection if it comes through this paddle and through that paddle. That way, any stray particles coming in from different angles are ignored. So it kind of says, no, these are coming from that direction. So they're coming from up. So they have a certain resolution in where they come from in terms of direction. Then you have these telescopes, which have these reflectors that can reflect light in the blue to ultraviolet, and they're collected at these collectors at the focal point. And these Winston cones, where the light comes in and scatters, is funneled into this piece, which eventually hits a photomultiplier tube and then produces some energy. So from here, you can sort of actually get sort of a pattern and direction on the sky as to where they are coming from. And then finally, the last type of detector, I chose this one. It's not really designed as a high energy detector, but everyone knows snow. And this one's designed to look at the sun and the neutrinos coming from the sun. If we understand the chemistry of the sun, then we know what to expect for the neutrinos coming from the sun. So they use a large tank of heavy water, and the reasons behind that, I don't really want to get into. It's a different experiment, but the point being, when a neutron comes in here, it hits a deuterium atom and ejects proton pairs, and this electron comes out, and the electron is traveling faster than the speed of light in that medium, and so it produces these shock waves, and all around it are these photomultiplier tubes. There's just literally thousands upon thousands of them, and from that they get a very good directional correlation as to where they're coming from, and they can measure the energy of that deposited in there. Okay, so back to this observatory. The observatory has quite a few elements to it. It actually spans several square kilometers. So I didn't have a chance to look it up, but you have the telescope over here that you can see, and these are special type of directional telescopes, but they sort of have a cone and they let the light scatter in and cascade towards a photomultiplier tube. They have pools of water on the surface that they use for shock detection of the high energy gamma rays. And these are photomultipliers, scintillator paddle type detectors. So these guys here. So there's all these different modalities that they use to analyze all the information that's coming from there. Okay, well, this, I thought that sometimes I like to dive off in the deep end and provide some extra background information at the expense of other things. That's what's new, but I thought this was worth it. So that's that for what's new. I hope you enjoyed it. If there are any questions, please let me know.
All right. I don't seem to see any questions there today. Thank you very much, Michelle.
Okay.
So the next thing
Oh.
that'll be happening for what I want to do first is just a thank you out there to Scott Young. He does all our behind the scenes stuff for the meeting, sets it up, as well as he's arranged for us to have our breakout rooms tonight, and we'll run them for 15 minutes. That will bring us back in time for our guest speaker, Wilfred Buck, who has joined us. So Scott, do you mind just explaining how it's going to work for the breakout rooms tonight, please?
Sure. So I've started up the breakout rooms, and you should see an option to join yourself. And so all you have to do is basically click on the appropriate one. Bob just found out how to do it, which is fantastic. Good job. As the person who created the breakout rooms, I can't see the same screen that you can. So I'm not sure exactly what it looks like, but you should be able to choose either social or imaging. If you go down to the bottom in the more section, there's breakout rooms there. And it's a little dialog box that you pull up on the side. So that's happening. And basically what those are separate meetings from the main meeting. So you can go join one of those, hang out in the groups for 15 minutes. And then I will close the breakout rooms when we're ready for our main speaker. And that will kick everybody back into the main meeting. So pick which one you want to go hang out in, or you can just hang out here, I guess, if you want.
I can't figure out how to
go-
get in.
Go down to the menu at the bottom of your Zoom, go to the three dots, the more menu, and then click on breakout rooms, and that'll bring up the menu.
Yeah, I'm
And
there, but I can't see how to join from there.
bottom of all
Sorry.
the list of names, at the bottom of all the list of names, there is social and there is imaging, and each one should say join beside it. So if you join with the one that you would like, and that should put you into the right place.
Yeah,
I
I'm
hope-
not seeing the join. Sorry. Maybe I'll figure it out eventually.
All right, well, thank you very much, Scott. So good luck, everyone. To join, just simply scroll down to where it says breakout rooms in progress. Scroll down to the bottom where it says social or imaging, and just click on join in the room you'd like to join. And we look forward to talking to you in a few more minutes. Bye-bye. As I'm going to the social room.
I guess I'm stuck in this room.
Yeah, I don't think it showed up for everybody.
Yeah, I mean, I can see the people joining, but I can't see how to join.
Same. I go to more, but all it gives me is chat and record on this computer.
Okay, so let's see. If you go to, let's see, more, all you get is record on this computer and chat, you say, hey?
Yeah.
You have an option for breakout rooms?
I see that option, but I can't get in.
Okay. Well, if you can't get in, Tara, which one do you want to go to? Because it looks like I might be able to assign you to a room. You want to go to social or imaging?
I'll go to the social one.
Send me to imaging.
You'd like to go to imaging? Okay, and right, you're Susie.
Yeah, sorry. It's hard to change
Yeah,
that when
it's
you
all good.
forget your password.
Let's see. Ben, are you out there? Do you want to join one of the rooms? Cliff, do you want to join something?
Yes, please. The social.
Sounds good. I'll put you in there and I'll figure out why it's not showing up for everyone. Okay, you should be in there now. Ben, do you have a room that you want to join? Oh, you're still muted.
I don't have a list of the rooms in front of me.
Okay, sure. There's the social room and there is the imaging room. So basically the social room is what we did last month with just everybody chatting. The imaging one is maybe a little more structured and a little more focused on taking pictures.
Okay, maybe I could go to the imaging room.
Sounds good.
Thank you.
Corinne, you're welcome. Corinne, would you like to join a room? Or Dan or Jerry? Actually, anybody that's out there still that wants to join a room, just unmute yourself, tell me where you want to go, and I'll put you there.
How do I get out of this?
So did people make it back from the breakout room?
Yeah, I'm trying to stop sharing.
We're back.
Yeah.
Excellent. Okay, I wasn't sure if you were going to get kicked out of the meeting completely or just brought back, but it seems to have worked, so that's wonderful. So we can again at the end of the meeting, I guess. If
I'm not sharing, am I? Can I? If I am, kick me out.
Well,
no
it
sharing.
just punted me back into the main meeting here.
Right?
Yeah, the breakout room. That way, no one can avoid coming back when the president calls. So when Dennis says, we all get yanked back in. It's good.
All right, so I think we're about ready to start. Welcome back, everybody, and for those on Facebook Live and YouTube Live, welcome as well again. I would like to introduce our guest speaker tonight, Wolf Buck, who is the author of Tippasquatty Kissick, Night Star Stories. Just hold it up here just so you can see it. And again, he's here to talk to us about the night sky. Over to you, Buck, and welcome to the RASC Winnipeg.
It looks like we might have lost him. I'll get him back, I think.
Oh no.
No, he's still signed in. Oh.
Hey, hello there.
Hello.
Good evening. Sorry about that. I just I kicked myself off the Zoom here.
All good. All good.
So are we ready to go here?
Yeah, it's all yours.
Okay. Well, first of all, I'd like to say, thank you, relatives, for allowing me to take up some of your day. I'm honored to be allowed to speak with everybody here today. And I guess I should begin just by introducing myself. Danse tu temanawak, Wolford Bucknet is Snigassen, Paskak Ninyoche, the Tamagin Totem. Greetings, my relatives. My name is Wolford Buck, originally from the Paskak Cree Nation in north central Manitoba. And I'm coming to you today from Winnipeg. And I've been invited to speak to you today about the Indigenous astronomy from, of course, from an Indigenous land, astronomy from an Indigenous lens. And so we're going to be discussing this picture you see in front of you on the screen. This is a star map. And this star map was commissioned about 5 years ago. And at that time, we located about 16 constellations. And since that time, we've located probably another, I'd say another 20 more since when this map was made. So the map has to be redone. But the thing about that is one of the things we should understand about Indigenous astronomy, Cree astronomy in Inyo, which I am Cree, and all other indigenous astronomy is that I found that from speaking with various nations throughout the world, indigenous people, that there are many stories. There's multiple stories concerning various groups of stars. And the Pleiades is a good example. So the way the Pleiades are situated, of course, in the sky, you can see them from the northern hemisphere and from the southern hemisphere at various times of the year. And that being the case, people from all over the world view that group of stars. So indigenous people have stories about the stars, and they don't have one story, they have 2 or 3 or 4, up to 7 stories about the same group of stars. So there's multiple layers in there, multiple stories being told. And depending on what point that is being made, or what telling what sacred story is being told, or what teaching, or what social norm, then that story is employed to apply to that group of stars. So you're looking at right here, if you look at that map, I said there were 16 constellations on here, but if you count the images, there's only 10 of them. So these this is an example of multiple stories. So if you look at the bottom where Orion is there's about 3 stories. They're overlaid within each other. There's about 3 images there, one on top of the other. And you can see Orion, and with the star Aldebaran is pointing at the Pleiades. So in the Pleiades, there's 2 stories in there. So I've been doing this research for, let's say, a good 18 years now. When I started full-fledged at it. Before that, I was just looking at the stars and mostly identifying the Roman Greek mythology. And of course, in the image there, you can see in the background in light blue is the Roman Greek mythology. And you can see the Milky Way running across that sky map. And in the foreground is the Cree stars. These are Cree stars. Inenyo Achagasak, we call them. My people call the stars Achagasak from the root word Achak. Achak is spirit. And we're told in some of our origin stories that we originate from the stars. We come from the stars. And there's various stories about that, of how we got here and how we come here. And and so the various stories it's on my clothes, G. Anderson. So the various stories come from specifically the Cree people. And so Anishinaabe people, the Ojibwe or Dakota, the Sioux people, or Siksika, the Blackfoot people, they have their own stories, they have their own constellations, and some are similar and some are totally different. And right across Canada, all the cultures, all the nations have their own stories, and some stories are similar, but it's depending on the environment, the animals that they talk about, because basically a lot of these stories are about the animals and the natural world. And so the stories are influenced by the environment that the culture is in. So like I said, when I started this focused and research about 18 years ago, I started with just one story regarding Cree astronomy. And of course, that one story had to do with one of the most obvious group of stars in the sky, the Big Dipper. And pretty much everybody can point out the Big Dipper in the Northern Hemisphere sky. And so that's the first story I'd ever heard. And this story was told to me by an elder from Kiniseo Sipi. Kiniseo CUP is better known as Norway House on the northern tip of Lake Winnipeg. And he told a story to us young people as one day, and he pointed out the stars of the Big Dipper. And the thing about that is the way he pointed the stars of the Big Dipper, and he talked about a story about Ocheek the fisher. Ocheek is what we call the fisher, and the fisher is part of the weasel family. So Ocheek the fisher and talks about the changing of the seasons, and the way the story goes is to make a long story short, it's about the changing of the seasons and how up in our northern hemisphere, around this latitude, these latitudes, it was winter all the time. There was no summer, and the animals got pretty tired of this monotonous, unchanging scene, and they heard from the birds that way down south there was no winter at all. And to make a long story short, so Ocheek and his buddies went down south and they brought back some summer for us. And so Ocheek was placed in the sky, and that piece of summer that he brought back, of course, is our seasons now, part of our seasons. A lot of these stories are fairly long stories, and they take in, like I said, they take in the environment that they're born in, and they take in the habits of the animals. They take in the seasons and the plants, and even the social norms of the people. So they take in all these things, and so that was, like I said, when I began, I started with that just one story. And of course, that was the story of Ocheek the fisher and the dipper. And since that time, doing a lot of the research, we found that I found probably about 7 stories about the Big Dipper. And there's all kinds of stories about the Big Dipper with all kinds of teachings. And a lot of them are ceremonial stories, and a lot of them are social norm stories, and a lot of them are things like about talking about how we should be treating other things, other beings, how we should be in a position to help, and if we are in a position of power, how we should be using that and not abusing it. So they got all these various things in the sky. So if you look at these images here, of course, the Dipper is that big bear on your left there, and Orion, the stars of Orion are on the bottom, and that group of stars, of course, seasonal stars. Orion, one of the names we have for Orion is Pipun Negate Tichigo. Pipun Negate Tichigo talks about the winter keeper. So it translates as the winter keeper. And so when it starts getting cold, Orion, of course, comes up in the sky, and he stays with us all winter long until it starts getting warm. Then he goes away, and then we don't see him again until then the following fall. And so he's standing there pointing. When I first saw this image, I thought he was pointing at the hole in the sky, the Pagwangizik, the Pleiades, because that's what our people call the Pleiades. We call them Pagwangizik, the hole in the sky. And I thought this is what this winter keeper was pointing at when he's in the winter sky. But what I just lately found out was that he's not pointing at that hole in the sky. What he's pointing at is another group of stars, a group of over 1 trillion stars called Andromeda. Because during one part of the winter, when it gets really cold, there are you can see Andromeda in the sky, and you can see the Orion Nebula in the sky, and that's a pretty cool part of winter. And that's when the winter keeper is in full power. They say over the winter months, when those two, the nebula in Orion, we can see with the naked eye in the wintertime. And those nebula that we see with the naked eye, or we call them Atsagwasquan. Atsagwasquan means spirit cloud. So you look at them and you see a faint cloud there, like just about like a fog. And same with Andromeda. When you see with the naked eye, it looks like that. So those two are called the spirit clouds. And when those two spirit clouds are up in the sky at the same time, and we see the winter keeper pointing at Andromeda, then we know it's really cold out during that time of the winter. And another, when you talk about the winter, is if you go right into the center of this image, this map here, and you can see a bird, and that bird is upside down, is right by a wolf and a turtle and a goose. Right there in the background of that, of course, you can see the circle of the precession right there. And so where that bird is right over Ursa Minor and Draco. And we call that the winter thunderbird. And the winter thunderbird, we're told, talks about at one point. I guess it's in relation to what the story about Ochik the Fisher and how cold it was at one point when there was no summer in this part of the world. So that winter thunderbird speaks about that. So it talks about the how cold it gets, and at some points the snow doesn't melt at all. And if you look at that bird, on its chest there's a star, and that star is called Mitaigizik. Mitaigizik means the heart of the sky. So right on the heart of that winter thunderbird, it's pretty much in the center of the precession, that cycle that our axis points around at the sky. And we're told it's a 26,000 year cycle. And so, and they say this knowledge that's been given to us has been handed down to generation upon generation upon generation. And if they could name that star the heart of the precession as the heart of the sky, then it just shows you that our people have been around here for quite a long time. Because again, that thunderbird talks about even ice ages. When you listen to the story about Ochik the Fisher and how cold it was at one point, and there was no summer in this part of the world. And then you look at that thunderbird and what it represents. You can see that they're talking about ice ages, so they're talking about quite a long time. And one interesting thing that I really found fascinating was I had the opportunity to speak with an elder. He invited me to go look at the sky with him outside of the city of Saskatoon at a place called Waniskewin. It's a heritage site on the plains, the northern plains. So one cool September night, we were standing outside looking at the sky, and we could see thousands and thousands of stars all over the place because there was no trees or anything to impede our view. And he was looking at that sky and he said, every visible star you can see with the naked eye in this sky, he was pointing to the sky, he said, had a name, had a constellation, had a group of stars attached to it, had a story, and had a teaching, had instructions, had a song, all these things. And he said, due to the historical trauma that happened to our people, about 85% of that knowledge base was wiped out. And he really gave me a real image that stuck with me. And what he said was that if you think of a village with 100 people in that village, and everybody in that village knows one word to a 100-word song. So when you gather all those people together and they recite their one word and they put them all together and they make that song, that one song represents the whole knowledge base of your nation, represents the whole knowledge base, of thousands of years of knowledge, right there, all together, and everybody contributes. I said, so one morning you wake up and 85 people are gone. And you're left with 15%, 15 people trying to figure out what that song was, if they could remember those words, and if they could piece those things together. And so the elder said, that's what happened to our people. Our knowledge base was wiped out. And this is not just knowledge about the stars. This is knowledge about everything. Because prior to the coming of the Europeans, there were fully functioning systems. There were logistics that could handle an infrastructure that could handle 1,000 people living in a village. So there was logistics that were involved in that, and they were fully functioning. And so this happened all over North America, that we lost 85% of that knowledge base of how to do those things, and 85% of that knowledge base about that sky. So every visible star we can see with the naked eye, we lost 85% of that knowledge base. So now we're slowly getting that knowledge back. But the thing about that elder told me was, he said, the way we come to knowledge is different than what you're taught in school about arriving at knowledge, about doing the steps. And of course, an example is the scientific method. He said the way we come to knowledge is different than what you're taught in school. The way we come to knowledge has some really stark differences. And one of the basic differences is achak, his spirit. Because our people are spiritual people, and everything is spirit. Everything in the natural world has spirit. And we're part of that. Everything. We're a little part of it. They said, part of that spirit. So all these things have spirit. And all these things are interrelated, interconnected. And all of these things affect each other. And so he's looking at that night sky and he said, the way this knowledge was acquired, it was acquired through Sundance. It was acquired through fasting. It was acquired through sweat lodge. It was acquired through shaking tent. It was acquired through teaching lodges. It was acquired through dreaming. And it was acquired through traveling and talking to people and sharing. That's how this knowledge was acquired. He said, now the thing about that is that, he said, is we still do these things. We still do these things. So that 85% of knowledge base that we lost is not really lost. It's still out there, and we can reacquire that knowledge because we still do these things. We just have to go out and make a concerted effort to do these things. And so that's one of the methodologies that the people use to coming to knowledge. And this is what the elder told us. That elder was named Ken Goodwill. He's from Standing Buffalo in Saskatchewan. And he's passed on now. He was an elder at the University of the First Nations University in Regina. And so he gave me hope that I could go out and I could reclaim the sky. And I'm slowly doing that. I'm slowly reclaiming the sky for the people, regaining that knowledge of the people that we've misplaced. And so, like I said, now if we do a map, I'd have to add about another, let's say, a good 20 more images to the sky, but some of them would be overlapping. To better get an understanding, we probably need about 4 maps, each one with the various images to show you some of the things. Another thing, one of the elders that I worked with taught me was that he said, up in the sky, there's 7 thunderbirds. They're up in the sky, he told me. And that's all he told me. And so far, I've located 2 of them. And you can see the one right in the center, which is the winter thunderbird, and the one right above, upside down, right at the top of the map. That's the summer thunderbird right over Scorpio there. So he covers Scorpio, he covers Libra, Serpens Caput. He's a pretty big image, sitting right on the Milky Way, right there. And this thunderbird is the summer thunderbird, Vipun. I mean, Nipin Pinesu. Nipin Pinesu, the summer thunderbird. And that summer thunderbird was the one that was in charge of cleansing the water, cleansing the air, cleansing the plant life, cleansing everything in the summertime. And one of the sacred ceremonies that our people do in the summertime is the Sundance. And central to that Sundance is Pinesu, the thunderbird. And for the Cree people, if you would take an image of a Sundance Lodge, a big circle, and for the Cree people, the Sundance Lodge has a door which opens to the south. And so everything that happens, they go through that one point, that southern doorway is what's used. And one of the things about that is that I was invited to a Sundance in Saddle Lake, Alberta. And so I attended and I helped. And during one of those nights, after all the dancers were resting, the elder took me inside that Sundance Lodge. And he sat me in the northern doorway of that Sundance Lodge, and we were facing south. Right across the lodge, there was a pole right in the center. The Ugumawatik, that sacred pole, which holds the Sundance, the Sundance flags, but also which holds the Thunderbird nest. So we were sitting in the north, and we're looking out that south doorway. And he told me, he said, look on the ground here. So I looked on the ground in the north doorway, and the sod was cut, and it was cut in the shape of a diamond. And he pointed to each corner of that diamond, and he said, each point of that diamond, there's a sacred being there. And one of those sacred beings is Pinesu, the thunderbird. And Pinesu, the thunderbird, is very sacred to our people. That's why when that Sundance tree is put up, we put that nest up there for the thunderbird to come and sit so we can cleanse us. And he said, this thunderbird is in the sky. And he pointed to that south doorway with his hand. And I looked. And I was mesmerized by that. And so I left that Sundance. And about maybe 3 weeks later, I was on a phone call with this guy from Iowa. And he was talking to me about the big mounds they have there in Iowa. These big burial mounds, or ceremonial mounds. They're not really sure what they are. Some of the people call them burial mounds. Some people call them ceremonial mounds. Some people call them maps. And then he was talking about that. And he said, there's this rock in one of those burial mounds. And I took a picture of this rock, and he showed me this picture on his phone that he had. And that picture was a petroglyph painted on a rock. There was a whole bunch of points painted on rock. And so he took that and he put another image beside it. So there were these double images of that those points on the rock, and he joined those points on the rock on one of those images, and he drew out a thunderbird, and he said those points there are stars. They're stars in the sky, and so there's that thunderbird in the sky. And right away, I remember what that old man told me, showed me about the sky. Told me about the sky. Noah Cardinal, his name was, the Sundance chief from Saddle Lake, and so I looked on a star map in the southern sky, and I looked for the image of that thunderbird. And one of the things that I found was that there's a triangle in the sky in the summertime. Just as it gets dark, there's a triangle, and that's Serpent Kaput, part of Serpent's Kaput. And I looked at that triangle, and I seen that triangle, and I seen the line of stars that go down that triangle. And then seen, as I watched it, it just like my mind opened up, and I could see the wings of that bird, and one of the wings went over Libra, and then it was covered. It was sitting on Scorpio, and it was right above Sagittarius. And one of the images I had is of that thunderbird sitting right on the Milky Way. So there it is, sitting on the Milky Way. And then if you go into a Sundance Lodge and you look if you stand in the north doorway and you look in the south doorway in the night sky in the summertime, just as it gets dark, that's the first thing you see is that big image of that thunderbird sitting on the Milky Way. And I thought that was pretty cool. That's pretty amazing that they knew that. And later on, when I was discussing it with one of the elders, he said, where that thunderbird sits, we try to make a image of it in the Ugamawatik, that Sundance tree. That's why we make the nest up there, because where that thunderbird sits, there's a nest right under it, and there's eggs in that nest. And I said, holy smokes! I wonder what he's talking about. Is he talking about the center of our galaxy, and that all those stars that are at the center of our galaxy, and those thunderbird eggs? Is he talking about black holes? So my mind was just racing with all these things, and but through this whole process of going to ceremony, through fasting, through going through all those methodologies, I've come to find a lot of these stories. And one of the things that when I started this journey, I was told by the elders, they said, what you're doing here has to be shown to our youth, because this is our youth's history. This is our youth's understanding of where they belong. This is who they are. This is the depth of knowledge that our people have. And our kids aren't getting this in school, and they should be taught this. But he also went on to say that with this process, if you are meant to do this, then things and events will unfold in front of you. And if you were meant to do this, then you'll acquire these things. And that's what happened. That's what has been happening, is that I've been following those methodologies, and I've been people have been talking to me, and people have been telling me stories, and I've been dreaming, and I've been fasting, and I've been sun dancing. So I've been doing all these things to help reclaim that knowledge of the sky. So I see it's after 9, so I'm going to leave it there. And I'll turn it back over to our moderator. And I'm willing to answer questions if there are any questions.
I have a question. Hi, Wilfred. It's Sylvia.
Hello,
And
Sylvia.
hi, we're so fortunate to get to have you present for us every once in a while. It's been a long time since we saw you last. And I always have, I always love these presentations, and, to hear your deep knowledge of Cree astronomy. And I have such good memories of some of the star parties that you held, actually. And we came with a few telescopes, and you had your group of people there and your portable planetarium. And now that we have the pandemic, I wondered, like, are you still able to reach out to your people and teach them these important stories that you're telling us? And how do you do it? Do you do it virtually like this, or?
Yeah, what I've been doing is doing nothing but virtual, of course, because the planetarium is totally shut down because of the enclosed space, and of course the schools are not open, and a lot of the communities are isolated, so we can't get in. So, and plus I've retired from Manitoba First Nations Resource Center, so I'm doing a lot of virtual stuff on my own, and hopefully when things cool down, we can get the planetarium going out again. But yeah, I want to, before I forget, I want to acknowledge the Royal Astronomical Society for assisting us in some of these star parties that we do. Awesome. The people are really impressed by the knowledge you guys have of the sky and knowledge of the equipment that you have. So thank you very much.
Hopefully we can do this again one day. And another thing I wanted to ask you about is that I saw on the news not that long ago that there was this documentary that won an important prize in Canada, and you were the star of that documentary. Is there a link or something where we can see it? I wasn't able to actually find it.
Well, there was a couple of things. One is we had the opportunity to name a star and a planet in our Milky Way galaxy in Cree. And the star and the planet, you can't see it with the naked eye, of course, it's too far away, but it's in around the area of Boots and Cygnus, in that area there.
All right, well.
And it's called the star is called Nekaway, which means mother in Cree, and the planet around it is exoplanet around it is called Awasis, which means child.
Child and mother.
Yeah.
Well, thank you so much. Really appreciate this, and I hope we see you again in the future.
Yes, we're hopefully we're planning tentative date in August, second week no, I shouldn't say August, second week in October, for another TPs and telescope star party out in the land there.
In Manitoba?
Yeah, just outside of Winnipeg.
Okay, maybe that's the same place where we held that other one, where you had.
Yeah, out in the big field there.
Okay, cool.
Yeah, but I'll let you know if you're interested. I'll for sure I'll let you know and
for sure.
Come out.
Yeah, would love that. Thank you so much.
All right, thank you.
Words.
Oh, go ahead.
Thank you. Can I ask a wisdom?
Oh.
My Cree isn't all that good. I gotta work on it.
Yeah, that was
Thank you for that.
Does anybody else have questions for Wilfred? And Wilfred, do you mind if I put a plug in for the book there that you've written as well?
Oh yeah.
Yeah.
So Tipiskawigi is it? That was the first edition. We put that out probably about maybe 2-3 years ago now, and I just handed in the manuscript last month, and it's in editing process right now. And I was talking to the publisher yesterday, and she said hopefully by July we'll have the new version out. So it'll be version 2. It's called Kitchikizik. I'll type it in here if I can type it. This is the new book that's coming out. It's called Kitchikizik, the Great Sky, and there's a lot more stories in it. And all that artwork that you see in that Tipiskawigi, we redone it, so it's all redone, and there's totally new artwork and a whole lot more stories. So by the end of July, that'll be out. And for those of you that might be interested, this year is my website. And on the website, there's I'd say about 16 stories that I recorded. And I always tell the teachers that they're welcome to use those in their classrooms.
Very generous. Thank you.
It's great.
Yeah, it's been really interesting ride. Just about 2 weeks ago, I was on a Zoom with from Calgary, and Dr. Corey Gray was he's a Siksika Blackfoot, and he was one who discovered the gravitational waves from two black holes. I thought that was pretty cool. And he's getting his mother to translate all those scientific terms into Siksika, into Blackfoot.
Oh,
It was pretty cool. All right. Well, if that's all the questions, I want to thank you for inviting me into your life, and thank you very much for listening.
Thank you very much, Wilfred. Have a good evening.
Thank you. Thanks for the link.
All right. Bye.
Bye-bye. All right, everyone. So what'll happen now is we'll just move into our virtual get-together. So you don't need to log into a different spot. You just stay on and continue on. And again, just a big thank you to all our presenters tonight, especially Wilfred, for sharing all his knowledge with us tonight. And certainly fascinating. And I certainly know that the council will support us, providing some support to teepees and telescopes in October. So provided we're all allowed to get together, we look forward to doing that. All right. Good night, everyone, and have a good one, and we'll chat again soon. Bye-bye.
Dennis, do you want us to reopen the breakout rooms as part of this, or just keep everyone in one large group?
Probably just leave everyone in one large group for now.
Very well.
Okay. Thanks, Scott. And unfortunately, I have to go, so I'll talk to you all later. Bye-bye.
Hello.
I was looking for these books. Oh, camera on.
There's a feedback back.
There's an echo in there. Okay. Gord, wait till he's back. Yeah.
Cracked open the beer. Pizza. One day we'll do it at Boston Pizza.
Oh yeah.
I've missed the most from this pandemic, I think, is the real face-to-face pizza.
Okay, how's this work? A little better. No.
Nope.
Bree's watching on the TV, that's why.
Gord, I have a question. What's the link? Remember the spectroscopy thing from a few months ago? I've been meaning to order one of those wonderful periodic tables. What's the link for that?
Just hang on a second.
Yeah. It works.
I keep wanting to get one of those gratings, but I have too much equipment and not enough time. So
time to use it.
Yeah. So I'm really focused on solar and regular stuff.
That should be better.
Oh yeah, that's good.
So you want it like the periodic table of elements as spectra?
As spectra, yeah.
Yeah, that's from actually our presenter a month ago. No, 2 months ago. His company, and I'll just pull it up here. He makes the RSpec software. And his name is escaping me.
Well, I'm going to see, yeah, RSpec.
It's rspec-astro.com.
RSpec.
And yeah, Tom Field, of course, was the presenter. He wore the clown hair and stuff.
Got it. Okay,
Okay,
great.
yeah. So if you go to that store, they've got that. I actually have that up in my office at work, the periodic table of spectra.
Yeah, I've been trying to put up some particularly sciencey looking posters in my study. And I saw that one. I've been wanting a periodic table, and I saw that one. I went, this is the one I want.
Yeah, it's really nice. Yeah, I put it in the frame. I put it up in my office, so it's a pretty nice poster. Yeah, and of course you can get his software and the star analyzer gratings that he talked about. You can get them, all that stuff from him. So it's a good store. If you're into spectroscopy. But you're not rich. If you're super rich, you go to shellyak.com, which is the Frenchman who sells $5,000 spectrographs and things. Yeah, I actually posted that spectroheliograph link before I realized that if you want to, it's a 3D printed spectroheliograph that you can view the sun in different wavelengths, including H alpha. But you have to buy, it's 3D printed, but you have to buy like €560 worth of optics to put in it. So that'll put a damper on that project for me.
Ouch.
And as I understood it, raster scans through? Like you take a picture and you look at it?
No, I don't think so. I think
it wasn't clear how it worked.
Yeah, I think you get a full. I think you get a full image. Yeah, the light comes through a slit, and you can tune which wavelength is coming through based on the slit, right? But even if you look at a star analyzer, you get the whole image, but it's spread across the spectrum. So if you're only looking at one wavelength, it won't be spread out. But yeah, that guy Christian Bull he makes a thing called UVEX, which is a inexpensive 3D printed spectrograph that, once again, you need a bunch of optics for, which costs a fair bit of money. The one I was going to build is another one that you can 3D print the device, but you need $600 worth of optics to make it work. So all of these, but that's much better than buying $5,000 worth of stuff from Shellyak, which is the next step up, right?
Well, it seems cheaper than getting a chromospheric thing from Quark, if I understand correctly.
Yeah. Yeah, that's the kind of stuff you save for. I'll be saving for my retirement when I don't have kids to buy tires for and things. Register their cars.
Well, then you get grandchildren. You have to buy for them.
Oh shit! Thanks.
Sorry, I'll go back on mute.
Thanks
here.
for bursting my bubble here.
You better buy now, Gord.
Yeah, I just got an invitation in the mail the other day to a virtual baby shower down in Maryland. I'm about to be a great aunt. Help!
Well, I've been a great uncle for a long time. There's a big age difference between my wife and her brother, so we became grand aunt and uncle a long time ago.
Mm-hmm.
Disturbingly young.
I'm glad it's a virtual baby shower. The real things make me go, ah! It's like,
so unfortunately, I didn't get this for the main meeting, but if you are interested, oh, that's backwards. Okay. How do I change that? I don't think I can.
Well, it's the right way. For you, it's backward. For us, it's
oh,
the right
okay.
way.
It's the right way for you. Good.
Yeah.
These books, I think Annette Lee is the person that Judy sent an invite to a presentation, but I think Wilford has been involved with these folks as well. And they've written, there's two of them. One is the Dakota Constellation Guide. And the other one, I think, is the Cree Anishinaabe group. And they're really good because they're not only like Indigenous star stories, but they're astronomy books, right? So it's interesting. You get the Indigenous sort of viewpoint, right, and the stories they tell about different parts of the sky, and then it does the astronomy as well. So these are excellent books. So they're on Amazon. Wilford's book's really good too. I was looking for Wilford's books as well as the second one of these, and no doubt they're on some shelf somewhere right next to each other. But yeah, highly recommended Wilford's book as well as these ones. I'm looking forward to his new one.
Yeah, I must admit now I'm not going to be able to look at Orion without thinking Winterkeeper.
There you go. Yeah. So I thought that was an interesting change of pace as a program.
Mm-hmm.
We'll I'll keep in touch with them, and we'll see what we can do if they're doing fall stuff. We can certainly get involved.
Yeah.
Fingers crossed that we'll be able to get out in the fall.
Oh yeah. Like,
I always like hearing those stories about the stars and the constellations. I remember I liked Gail's stories. Those were nice too.
Well, it'd be great to get Wilford out to the star party and sit around a campfire and hear stories, right? That'd be incredible.
Yeah, no, that was a real eye-opening kind of presentation that he gave, and like I'd been saying before, I found that one article online with Science Friday about it, about Wilford Buck. It was back from 2019, but it was very interesting that he has that portable planetarium, I guess, that he takes out.
Yeah,
which is very cool. Yeah.
I'm just looking at the article that Tara forwarded. Is there a link to the actual documentary in there, Tara? Or oh, she's not here.
I don't think she's on now.
Hot docs. No, we'll have to chase that one down. I'll keep in touch with Wilford, and we'll see if we can get it and figure out how to make it available. Maybe we could watch it at the Spruce Woods or something.
Yeah. Well, if you're interested there, I just put the link to that article in the chat. But if you scroll down in there, that picture that Wilford was showing is in there. There's a group of 3 star pictures in one image. And so there's one from the Ojibwe.
That was created by these people.
Oh, okay.
Yeah. If you go to the site for these books, they're available online.
Yeah. Okay. Cool.
They're very cool.
Mm-hmm.
Yeah, Ojibwe, Lakota. So they've done a book on the Ojibwe. They've done a book on the Dakota, Lakota, and I assume there's one on the Innu Cree coming soon. So it's very interesting. Very good books. Cool.
Are those recorded stories there on that site?
Yeah, there's a few, looks like.
Yeah.
must be incredibly hard to recover stories like with, especially if they're more than a generation old. Like that must but I guess there are clues and things like that thing with that petroglyph with the stars on it. It's stuff like that.
It's like doing genealogy. You have to catch the older people before they leave us, right? So because they're the ones who have the knowledge.
But his point that they've been decimated culturally is well taken, right? There's been 400 years of suppression of culture, so that doesn't bode well for being able to hang on to things like their the indigenous stories, right?
Yeah, when you said that that big loss of all that, it reminded we always talk about the loss of the Library of Alexandria, and this is easily sort of at that scale, just in the one area. And can't imagine what a monumental task it is to try and rebuild that.
Well, and I think it's like you said, you're going to get 15% back, and the rest is lost, and that's a tragedy.
But yeah, that's sort of the same thing I thought about Alexandria, and how it seems that the newer cultures come in and wipe out a whole lot of knowledge of the older one.
I don't know. I think it's the the mob comes and wipes it out. Sometimes in that case, right? It's kind of like what's happening in the States right now.
Yeah, if you're lucky, people tell stories within their own families, and those stories, they might get slightly mangled, but the gist of them might get passed down, and then somebody can bump into somebody else who has a similar story, and they go, oh, and they go, I think we got something here.
See you, Mike.
Hey.
Does anybody know what the name of that book was? The first book that they talked about?
One of the books was Kitchakisik, The Great Sky.
That's the one that's coming out now.
That's right.
Yeah, that's also, isn't that also the name of his website?
No, his website is, well, I can spell it, ACAKWUSKWUN.com. I wrote it down at the time, and Sylvia sent an email.
I'll put that in the chat.
Tipiskawi Kiwak Kizwak is Kizak, I guess.
There, I just put that in the chat, so you can and you'll go to his site.
Yeah, this is the book name.
Oh, there's new book announced. It's listed on.
I got it from McNally Robinson. You can order it from McNally. Well, $14.95. I think that's the only place that carries it.
Oh yeah, it's a portable planetarium.
Yeah, he would go to indigenous schools and do presentations. That's what he did for the organization he worked for. I guess he's retired from them now, but he still has the planetarium. That's interesting.
Looks like sort of it's inflatable.
Yeah.
Yeah.
That's like the one Lindsay used to go around with as well.
Well, that was my first job with that inflatable planetarium, driving around to every town in Manitoba, eating at the Name of Town Motor Inn, and
blowing up your observatory.
Yeah, all the inflation process was always the highlight. You turn on the fan and it goes like a big jiffy pop.
Cool.
Yeah, it gives a new meaning to like inflation of the universe.
Yeah, somebody has to go. Eh.
I did not see that one coming.
Just in a silly mood tonight.
So if you're wondering if you're hearing ambient noise, I'm actually printing out a telescope mount. So it's going to be like,
Oh, got a 3D printer there.
yeah, it's
Cool.
about 60 hours of printing.
Yeah.
So how easy is it to design something for printing?
Well, I didn't design this, I just downloaded
Oh.
it, but if it's pretty easy actually. Fusion 360, you can get a free version for hobbyists, which is fully complete, and once you figure it out, it's actually pretty easy to build 3D stuff. I use it a lot for little bits and pieces for telescopes. Like I needed to make a plug on the end of an aluminum tube for my telescope. So I just designed it in Fusion 360, printed 12 of them out, which took forever. And that's what I use for, connecting my telescope tubes to the body of the telescope. So it's convenient. Otherwise, you need to be a machinist and have a lathe and all that kind of stuff. It's expensive.
There must be places in Winnipeg where you can access a 3D printer, just give them the plans, and this is what I want.
Well,
You
yeah,
do that
there's
online too.
maker spaces, and when I printed out the motor mounts for my other mount, I sent them to a guy and he printed them and mailed them to me. Basically, it's expensive though. It's really cheap to print stuff. Like filament is quite inexpensive. It just takes forever.
You can do it on the library. The Millennium Library has a 3D printer that they'll let you use. Yeah.
You just have to sit there for 14 hours and wait for it to print.
What does the stuff print out as? I mean, what's the material?
It's a filament. It comes in a spool. This is just took off, right? It comes as a spool.
Oh yeah.
Looks like an old computer tape, and it's little, very thin plastic filament.
Oh, okay.
And basically the head of the printer melts the filament and lays it onto the what you're printing. Like the printer bed is heated. So it sits like for PLA, it's not as hot. It's only about 85 degrees, but this is ABS, which is like Lego, basically the stuff that Lego is made out of. You have to print that at, I think the bed temperature is 110 and the nozzle temperature to melt it is like 240, right? So that's why mine is in this weird enclosure thing, because for ABS as well, it has to heat up. So any cold air currents will cause it to lift off the plate. And so it needs to be in an enclosure. So that little enclosure keeps everything hot, right?
Is it toxic?
No, it doesn't give off toxic fumes. It's not, it's just melting it. It's not burning it, right? So it's not outgassing. Not much. You can smell it. As you can see, I have it sitting right next to me. I don't smell anything.
Thought of melting plastic is like, oof.
Yeah, but no, it doesn't smell too much. It smells hot. When you're doing ABS, oops, there's a dog saying hello. When you're, oh, I think I'm done. The dogs are about to start playing. When you're melting ABS, it just smells hot, right? It doesn't smell like burning plastic. It just smells like an oven.
Was that the dog there?
Yeah, we've got one dog, like, yeah, she's very vocal, but she sounds like